Sandhya is a senior developer advocate for 8 years or more in applied AI research. She specializes in large language models and agentic AI systems. She has developed and deployed AI solutions at organizations like Amazon, Warner Brothers, and Fidelity Investments. Her work centers on turning cutting edge research into practical applications. And she's very passionate about helping others, developers build intelligent systems that will solve complex problems. I know AI systems and everything is definitely the new topic. And thank you so much for sharing your time with us today. I will stop sharing and Sandhya, thank you so much.
Thank you for having me. I'm excited to talk to all of you today and everyone who's going to be watching this later on. And if there are any questions at all, please feel free to reach out to me at any point in time, and I'm happy to chat in and check in with all of you later. So thank you for the introduction. My name is Sandhya. I also go by Sandy, if that's easier. And I've been in AI applied research for like many years now. And it's amazing to see how this world has evolved. How back in the day it used to be so difficult to get your model to even predict the sentiment. When I say I don't like this food, is that a positive sentiment or is that a negative sentiment? Just building a simple model to predict that would be such a difficult task. And now we're in a space where we have LLMs and all of these amazing generative AI models and developments that are able to write for us and create images and create videos and do all of this amazing stuff for us, right? And so, where does this leave us? What value do we add? How do we use this capability to do better at what we really enjoy doing? And how can we just make best use of this amazing technology, right? And I love talking about the things that I'm working on, sharing with women. It took me. I needed a lot of mentors and friends and support to get to the space that I am. And I would love to give back to the community and empower each other, right? We all grow together, we support each other, and we make sure we're on top of things as much as possible. So I want this to be super interactive and fun, and there are no wrong questions or wrong answers. But I would love to get a feel for where everyone's at, and then maybe take it from there. So before I even start sharing my screen, and today I want to talk about self-improving agents. AI agents and how we can even use that and why it's so cool, right? Um, but before that, I sort of want to get a feel for everyone's understanding of AI. I'm sure everyone's heard of it and everyone knows what agents are, but just so we're all on the same page, do we have what do you guys, what do you ladies think agents are, and what do you think it's about?
For me, myself, I would definitely, agents can seem kind of intimidating, right? And so I tried doing some, like some examples and things like that, but it's really cool what you can do, and I'm excited to learn from you.
No, totally makes sense. Then there's so many buzzwords out there on what agents are and what we do with them and how we use them and how we build them. There's so much going on that sometimes it's hard to even like really understand what is an agent, right? So even before I get into self-improving agents, and because this time I get to do this online and I have access to internet, I actually do. I'm a part of me is thinking maybe I should wing the initial part of it and talk about the difference between, like, actually introduce what an agent is, right? Start from the basics. Now, now, we started, like I said, we started with in a world where we used to build models that would just predict the sentiment, sort of like classification or like clustering, where we would have where we would want to segregate all our data points into certain buckets and say, this is class one and this is class two, or say, this is this type of a classification and a different type of classification. That soon changed into a world where now we want to predict the next word of a sentence. So if I usually say, what is the weather in New York today? The answer typically would start with the weather in New York, right? That's typically how it's supposed to start. And we know this because we understand English innately. We know what comes after the other word. And so we had to build models. We had to build these large language models that are really good at understanding the next word prediction. And essentially, this is the power of LLMs, but this is also where LLMs are like they fail. This is the reason why we get wrong answers, because at the end of the day, it doesn't matter how good they are just predicting what the highest probability of the next word. And so the research labs have have built these huge models trained on all of the data that exists in the world. And so they've shown it so many different types of varieties. So now it's got a good understanding of language. So it's great at chatting with us. It's absolutely phenomenal at chatting with us. But what it cannot do is it cannot give us the right answer to the question by itself. It cannot give us the right answer to the question based on, and we call this the pre-trained data, the data that it was used to be trained on, because that data is limited. It's limited to the last date on which it has been trained. And so what that means is if it was trained on a data that said the weather in New York is 83 degrees, and this was in 2025 or like December 2025, it's only going to remember that. And because it's seen only those numbers, it's just going to throw out one of those numbers. And this is the concept of what's called hallucination. That's why we think they hallucinate, because they just predict based on what they've heard before and what they've been trained on before. So they just say that, right? They don't really know what they're saying. And so, how can we fix this? Right? What is the solution to fixing this? The solution is not to use a large language model by itself, but to give it access to what we call tools. And so, what are tools? Tools essentially are APIs. They could be APIs, they could be your databases, they could be any source of truth, any source of information that is current, that is relevant, and that will help the LLM give us the right answer. So now imagine if I can give it access to the weather app. Right? There is a weather app that we all know. Let's say I could give it access to the weather app. Let's say I have a tool that can go look up that weather app and search through it and give me the answer. Now, what we can instead do is, and so what again, research labs have done is they have trained LLMs to not just predict, but to figure out which is the right tool to call so that they can go look up the tool and execute the function of that tool. And this tool is super deterministic because this tool can either go search the web for your answer, like a question that you ask, or the tool could be something that already has the answer baked into it, so it can just retrieve that information, look up the database and tell us. Or it could be what we most frequently use these days are the coding agents, right? They could have an interpreter, something, a code writer that can write code and execute code in which way, which is how these days they don't make as many mistakes. That's how they're able to give you the right output, because it is deterministic. It is no longer probabilistic, and your LLM is not guessing what the answer is. It's deciding which tool to call, and that tool will then go and deterministically get the right answer for us and give us the result. And so an LLM, and so this tool is sort of called the harness. And so the LLM, along with the harness, and tools are just one part of the harness, right? Because another problem that we have with LLMs is we try chatting with them and we tell them so frequently, hey, don't use M dashes, or like, don't write it this way. Please write in a different way. Please refer to me as this. We try talking to them and telling them all of these things, but they just seem to forget. They can never seem to remember what's going on, right? How do we fix this? We have to give it access to memory. We have to give it access to short term memory or long term memory or session memory. And then they would actually have knowledge of what's going on. And so that is a different piece of harness. And so there are all of these different components to a harness. And so the model, the large language model, plus the harness, and give it that loop where when the user asks a question, the model thinks and the model decides what to do, and then it calls the harness. It calls one of the tools. The tools then get executed and they give us a response. That response then gets fed back into the LLM, and the LLM would then construct an answer based on the question we want, because it's just getting the answer, right? Like, let's say, what's the weather in New York? It would do a search, it gets the weather and it says 92 degrees. I don't know what the weather is, I'm making it up right now. But if it says something like 92 degrees, it would pick up that answer, tie it in with what it's actually supposed to be responding with, and then it would say, oh, the weather, thank you for asking. The weather in New York is 92 point something degrees. What can I help you with next? Right? And so it then is able to put together all of that and then give us the answer. And this loop plus the harness plus the LLM together is what is called an agent. And and so there are agents that you use, and then there are agents that you build. Two types of agents. Agents that we use are sort of like your chat gpt. They're like your codex. They're like your Claude code, right? They're all of your cursor. They're all of your they are the agents that we don't necessarily code. We don't write how to write an agent, but the agent is already fully constructed. It knows what it's supposed to do. It's got everything set up by whichever company and research lab and whoever is making it, and we are the consumers and we use it to then let it help us build whatever we want to build. But today, I want to talk to you about what it takes to build one of these agents, right? Forget just using them. What if you want to build a very specific agent that you want, and you want it to do a very specific thing? How can you get it to build that very specific thing and not use a different agent to help you code your way through or do something that it's already set out to do, right? That's what we want to learn about today. And taking it a step further, what's even more cool is how can we build agents that improve themselves? How can we build self evolving agents? Agents that have access to no tools whatsoever, but they're so smart that they can write up tools by themselves. Right, so I'm going to dive. I want to start diving straight into our demo. Like, I have two demos. I have two things, and it's fun. We can have fun with it. I want to give you a teaser of what I'm talking about, and then we can look into the code and look into all of the fun stuff. Before that, do I have any questions so far? Are all of you with me, or is everyone like, what is she going on about?
I'm locked in. I'm trying to learn. Very cool.
Amazing. Amazing. Awesome. So I'm gonna go straight in. I'm gonna start sharing my screen. Okay. So you can see my screen, right? So here, what I've got, and I'm guessing all of us are developers. I know most of us are front-end developers, but in this case, I'm going to be showing you a Python code. And fun fact, you can use your code editors to write this up, and you can use it to build something like this. What I want to leave you with today is how powerful this idea is, and how we can all start from scratch and build this up. up. And so this is an agent, and this agent is less than 65 lines of code. This agent currently has access to no additional tools. It's just got three built-in tools, right? And there is a system prompt here, and we usually have to write a system prompt so that we can tell our agent what it's supposed to do. And this agent currently has no tools in its folder, which means every time you ask it to do something, it's supposed to hallucinate, right? It's if you ask it, count the number of R's in strawberry, it's probably just going to make up an answer and it's going to predict what it thinks is the right answer, but it could so often get it wrong. And but instead, this is what my code does, and let's see how powerful it is. If I, okay, so I'm going to start running it. I'm going to say, let's do Python 3 agent.py. That's the name of this file, right? And it's got no tool that can do anything else. So now I'm going to chat with it, and it's saying, ask me to create a tool and then use it. So this is an agent that knows how to write its own tools, that can write its own tools for you on the fly depending on what you ask it to do. For example, if I say, hey, let's start with something simple. Uh, Count the number of characters in in the word, in a word. Okay, you know what? Let's just say in the word strawberry, and we can play around with this. Okay, so let's say I say this. Now, what it's going to do, it's not just going to make up an answer and tell you how many R's are there. It's going to create a tool if there's nothing existing. So it's calling its own tools and it's loading it. And you can see now there was no tool. Now there is a tool called count characters. So on the fly, at runtime, I didn't have to redeploy this. I didn't have to change anything. At runtime, it's able to write its own tool and it's able to say, okay, this is a tool that can now count the number of characters in strawberry. And so it says the word strawberry contains 10 characters. And this is so powerful because now it's not hallucinating, because it's writing a tool that's doing it. Right now, let's say I don't like it. This isn't good enough for me. I'm gonna say this is not good enough, right? I mean, sure, it can count the number of characters in strawberry. If I give it blueberry, it'll be able to do a good job. But I wanted you to say count the number of R's in strawberry. So now it's again not hallucinating. It's saying, you know what, let me count, create a tool to count specific characters in a text string and then use it to count the number of hours. So it's so, and there we go, it's already written. Before I could even finish speaking, it's already written count specific characteristics. So this, it's programming itself to be able to answer questions without hallucination, because it's able to write tools by itself. So now it's going to count the number of hours, and now it's going to start loading it. And then let's see, for whatever reason this is hanging, it's supposed to quickly be able to load it and write it. I'm gonna see if I can chat with it again. Count the number of hours in strawberry. Come on. Oh, yikes. It's hanging on me. I think my internet has given up on me. Oh man, may the internet gods be with me today. Come on, don't hang. Because it's usually just supposed to load and then it's supposed to call the tool and then it's supposed to do it. But I don't know why this isn't loading at this point. Let's see. Let's give it 2 more minutes and then else I'm gonna just quit and I'm gonna start again if it doesn't do it. So quit. Is it even? It's hanging. It's not even quitting. It's not doing anything I ask it to. It's hanging right now. Oh man. Terrible time to have bad internet. Ah gosh. Come on, you can do this. You can, like, please don't hang on me. Worst case, I'm gonna do control C and I'm gonna force quit. Okay? It's not even control Cing. Ah man, my editor stuck. Looks like such a terrible day for this. Let me see if I can do it on an. Oh no, wait, something happened. Ah man, there we go. Ah, so it just started working. It was like, now I'm gonna do it, and it started calling it. It actually did count. If we noticed, I think it was hanging because my internet was really bad. It loaded the tool and then it saw all of this. It's like, I'll count the number of hours, and it called the count specific characters, and it actually says the letter R appears 3 times in the word strawberry, and that's the right answer. Right? Okay, so I'm excited. Let me try this again. Python 3, Python 3. You can see my screen, I'm hoping, right? Python 3. Yikes. Come on, come on, come on. Python 3 agent dot py. If you can see my screen right now. Okay, I don't know how to pull this to the bottom, but let me do Control F so you can see it bigger. Okay, once more. Count, give me a name. Okay, so I'm gonna say count the number of A in Sandhya Subramani, which is my name. Another demo, right? So now it's because it's already got the tool, it's not rebuilding the tool. So it's saying, okay, you know what, let me check what exists. It's saying, oh, it's got, and then saying, okay, I'm gonna create it. Now it's saying, I don't need to create it, I'm just gonna load it. So it's gonna count the number of characters for Sandhya Subramani. So then it's saying, this is the position. Now it's even doing the positions, right? I think that's why it wrote up a new one. So it's like Sandhya A position 2, Subramani position 5, 7, and 12. So it's actually trying. It's actually really trying to do a good job of what I'm saying, right? And so how cool is it that we can now get it to do things without us explicitly telling it what to do? Right? How cool is it that giving it zero tools that we write it ourselves, this is able to do it. So I'm going to jump straight into how we can now start building this. This code can look big, it can look confusing, but it's honestly not. All it requires is 5 lines of code. That's all you need. So let's get started. Do I have any questions so far? Okay, I'm gonna assume that is a no. So this is me. This is my LinkedIn ID. If you wanna send me a request, connect with me, bother me with, but I wanna say bother, like ask me questions later, and I'm gonna be more than happy to connect with all of you. So
Awesome.
let's get started. First thing. I present to you Strands Agents. This is a open source framework. This has been built by AWS, and we built it 3 years ago. Fun fact, before agents were really a thing. But we decided to open source it because it was so powerful, and we wanted to give back to the community. So we said, you know what, we want everyone to be able to use it. And so this is what is called an agent harness SDK, which means this allows us to build our own agents. It allows us to write our own tools. It allows us to add memory. It allows us to add all of the different components that we need to ensure that we're able to build a good, reliable agent in production. If we want to build agents that can do things for us. And this is super lightweight, super easy, and it's very powerful because you can bring your own LLM. This works with all types of LLMs. This works with your OpenAI LLMs, with your Claude, this works well with your Hugging Face models, with Light LLM, with anything. So you can bring your own LLM and this agent will support it. And it's amazing because now you can even swap out different LLMs and see the performance. You don't have to change the system prompt each time. You leave the exact same system prompt and you can change the LLMs and then you can see how it performs. So it's even more powerful because you can check how each of these LLMs are doing head to head. So you don't have to change your entire framework. Today, let's say say you're using the latest model that exists. Tomorrow, another version comes out. You don't have to backtrack and be like, oh man, I have to rewrite the entire architecture. This remains the same. All you would have to do is replace that one API key that you bring, which, so use your own favorite one. Just feed that in, and this works. So it's super powerful, super friendly, and easy to use. And it supports MCP, your model context protocol, your A to A agent protocols, which allows it to talk to other agents, which allows it to connect to different types of tools. So it's really nice and really fun. And you can use it straight off of GitHub. All you have to do is a pip install, and you're there. Now, how does this work, right? How do you get started with it? What you need is two things. A, you need to say from strands import agent. Then from strands tools, which is the tools library, and this is also there on GitHub, and it you can use it. These are pre-built tools, and tools that we've built alongside the community. And one of them is the shell. Now you can write your own custom tools, like in the demo that I just showed you. We can get it to write its own tools, but there are these pre-built inbuilt tools also. One of them is shell. And so how you do it is just with this one line of code where you invoke agent equals agent, and you say tools equals shell. And then you ask the agent, what can you do? And it is supposed to be able to tell you exactly what it can do, which is using shell, and it's able to talk to you, and it has an understanding of what goes on under the hood. That's all it takes. Now, going back to the code I've given it access to just three tools. And let me get back to that, right? So, first thing is with self extending agents. I'm going to show you this, and then I'm going to show you my code so you get a better understanding. So, how do you build an agent that improves by itself? By giving it access to pretty much just three functions or three tools. The first one, as we see, is shell, which means it needs to have access to your directory, so it can see a list of all the tools that are currently there, a list of all the documents that are currently there, so it can manipulate it. And then what we give it are the system prompt. The system prompt essentially tells it what a tool looks like. So we say, hey, create a tool for yourself and start using, and then we tell it how to use the tool, where to look for it, what a tool definition looks like, which means it has the add tool decorator function, what a sample tool looks like, and then we say system prompt equals system prompt. That is all the system prompt is. In the system prompt, we give it an example of what is a good tool, and then we give it, apart from tools, we say load tools from directory equals to. What this means is it allows for dynamic reloading of tools, which means at runtime, without you having, so in my code here, right? And then here you say create 5 tools for yourself. So in my runtime, when I'm running Python 3 agent.py, I don't have to like end it and restart it. It starts calling the tools, invoking the tools at runtime while it's already running. So when we started writing, we said, you know what, let's just create this as a parameter over here. Instead, what we also did additionally is we said, you know what, let's just give it access to editor and load tool, which is exactly the same as dynamic reloading of the tool. So now all we give it access to are 3 tools. The editor, the shell, which gives us access to the shell and the directory, the editor, which allows us to edit files in the shell in a directory, and the load tool, which allows us to load it as soon as it's been written. And like I said, the system prompt is just telling it what it is, and it tells it how to create a tool, what the template's supposed to look like, the tool specifications, and the rules. Right? Like make sure it's always here. Make sure you always write it here. When you use it, call it directory, and all it takes is one line of code. where I say system prompt equals system prompt, and the three tools that it's got access to are editor, shell, and load tool. All of this is just because I want to chat. This is just for the boilerplate code so it can continuously chat with me without breaking. That's all this is for. So all it takes is one line of code, and now you have an agent that can write itself. Correction. The agent cannot write itself, the agent can write tools, but now let's slowly upgrade to whether an agent can do more than that. So I jumped ahead of myself, right? So now I want to get to, can agents build their own agents? So far, how are we doing? How are we doing? Do I have any burning questions? Thank you, Sophia. I'm glad you're enjoying the talk. Okay. Oh, yeah. For those of us who want to go beyond the basics and really dive deep in AI, what course or learning path would you recommend? Of course, I would. Right after this talk ends, I would love to share resources with you. We actually literally just launched this trans course. One of my teammates is making it, and I would love to share these resources with you and how to really learn about this. I have a bunch of courses, so I will share resources. Thank you for that question. Anything else? Any other questions? Okay, awesome. Moving on then. And I want to give us like another 10-ish minutes towards the end so we can answer questions and deep dive and do more fun things, right? So, can agents build their own agents? And wink, wink, I already gave away the answer. And the answer is yes, yes, they can. And I want to show you how we can do that, right? So, next slide. Before we get into agents building their own agents, we need to understand what type of agentic patterns exist. And primarily, there are three. So, one is called the swarm, which means it's co collaborative. So, you have an agent one with an agent two. So, why do we need more than one agent, right? Let's actually get down to this. Now, an agent is really good at doing one specific task really well. And if you overload it with a bunch of different tasks, it sort of gets confused. It struggles to figure out how to get it done and it doesn't do anything properly. So it helps if we have multiple agents that work on different aspects of the problem and they all come in together and then they solve the larger problem for us. So, in that sense, Swarm is sort of, think of it as a co collaborator. Think of it as you and your teammate working on a project together, and both of you want to solve that exact same question. So, both of you bring in your own opinions, and both of you decide together and then take an action, right? Both of you want to decide and determine together which is the best way forward. If you want your agent to do that, if you want one agent to research about one area, another agent to research about another area, bring in answers from both areas, and then have them co collaborate and then come up with an answer together, you would want to use something called a swarm where they work together. But then you also have graphs. A graph is one agent pretty much handing it over, the answer over to another agent. So let's say you and your teammate together did your own specific research and you collaborated and then you have an answer. Now, but you may not necessarily be the ones implementing it, right? Like think of it as your UX and your think of it as like someone doing all the user research and the user experience and what it's going to look like when you're building a website, right? So someone's going and doing all of this amazing research, but they may not be the best person to go and build out the UI itself, right? They may not, while they might know what looks good and what is best, and they may not really understand the details of how to get it done, and they may not have the proficiency to get it done as quickly as the experts. So they would then want to hand it over to like a front end expert who's great at spinning it off straight from scratch and they know exactly what they're doing. In cases like that, we would want to use something like a graph. where the first agent does something and it says, okay, this is the information that I found. Now use this and do something with it. And the second agent then knows what to do with it. So then it uses that answer and then it finds out its own things and it gets you the answer. And then you get all of these things together, and together, all of this will form a workflow. A workflow is basically a combination of swarms and graphs and all other structures that you can think of with agents, and then use it in a pipeline to be able to get your results in a dependable way, in a reliable way, and the order of the dependencies are fixed and they are repeatable. Let me show you an example, right? Like a workflow could look like this. A workflow, you could have your main agent spin off, and by the way, this might sound like it's a lot, but it's not actually a lot, because where I'm getting to, wink wink hint hint, is that we can now get agents that write themselves. You don't even have to do all of this creation. You could if you wanted to, but if you really didn't want to, you don't have to, because now your agent is powerful enough to do it by itself. So now again, now I'm spinning off four of these create sub agent tasks, right? And I'm saying I want four different subagents that solve something in parallel. All of them spin off at the same time, but this one, after getting its answer, is supposed to call one more agent that then goes to two other agents here, again spinning off in parallel. This one is sending off to three different here and three different here, and you're thinking for 10 different cycles. So this is super sequential. This is a swarm where they're all co-collaborating. Like this one does it independently, and then these four are thinking together. Here it then goes to a graph where one points to another, and there's something else here, and then there's here, right? So workflows can be as simple as you want it to be. They can be as complex as you want them to be. And each of these are just different types of tools or agents that you can call, right? So this is what is a workflow. Now, before I get to the next slide, I want to show you how this can look in practice. Is everyone excited? Is everyone with me? I'm just trying to check, take a feel for what everyone's thinking right now. Let me zoom in the meantime. By the way, I'm using this editor called Kiro, which is also something that AWS built. It's a really cool code editor. It's sort of like your cursor, yeah, it's sort of like Claude Code cursor, and you can vibe code, you can give it specifications, you can give it your requirements file, and this will build out everything for you. So Kiro is pretty amazing if you want to use that. So, same thing with agents, right? I've given it access to the exact same three tools: editor, shell, and load tool. The difference here is I'm telling it that it is a meta agent architect. And I'm telling it, instead of creating tools for itself, I wanted to go create agents for itself. So now I'm saying, you know what, keep it simple. I don't want you to do swarms. I don't want you to do graphs and workflow. I don't want you to do all of that. But whatever I ask you to do, please just break it into three to four sub agents, right? Two to four sub agents. Print your plan. And then I want you to write each sub agent as a tool file. That is how this works. It considers every agent, sub agent it creates also as a tool, and so it uses it the same way. And I'm saying it, write it in that same location. This is how you use it. This is how it looks. This is an example of how it looks. These are all the rules, and the exact same line. The exact same line. Nothing's changed. It's just that in the system prompt, I'm telling it it's a meta agent architect as opposed to a meta tooling architect. And so it's able to write agents by itself. Now, I'm over promising. Again, may the demo gods be with me. May my Wi Fi god be with me as I do this right now. Okay. So let's give this a shot. Let's see what works. Bam. Okay, so it looks like it's on. So I'm gonna see, and I'm gonna say, right, be help me plan my vacation to Oahu in Hawaii. Okay, whatever. First place that comes to my mind. If you have a better place in mind, I'm game. Are any of you traveling? Do you want to give it a shot for any of your travel places? Actually, yeah, that's a great point. Do any of you have any travel plans coming up? Where should I ask you to take us to? Oh, and great question. I'm going to come to this in just a bit. Is someone talking? No, it's just me. Okay. If there's any other place you want me to ask it to do, please put in the chat. I'm gonna add it. Oh, Hawaii sounds great. Perfect. Thank you, Gina. And while it's thinking, I'm gonna answer the other question. Okay, so honestly, it's actually starting to build it, right? So it's saying I'm gonna focus, do three focus sub-agents: destination researcher, itinerary planner, packing advisor. Very cool. I didn't even tell it what to do. It's starting to do it, and it's already creating it as we speak. There we go. So it's actually creating its own tool spec, right? It's saying destination researcher, description, input schema required, and it's creating its own tool use. It's saying this is what it's supposed to do, this is the agent. It's spawning off its own agent, and it's writing its own system prompt for that sub agent that it's writing up. And it's telling me what it's supposed to do, what it's supposed to look like, best neighborhoods. It's asking it to do these things, right? Second one, itinerary planner. It's writing the tool spec. It's writing, again, it's written its own system prompt for its own sub agent, because this is our main agent. These are all of the sub agents that have been written by themselves by Strands agents, which is our main agent. And it's actually, oh wow, my internet seems to be great right now. It's actually starting to give me the answer, right? So now it's saying plan. Three things, and now it's loading all three tools. Loaded, let me run them, and it's saying complete first timers travel guide. So it's actually giving me all of these things: hike this, do this, so it did not have any of this information in the agent. It invoked the sub agents, which were then very, very good at doing what they're meant to do, and it's giving us recommendations, because I wasn't super super specific about what I wanted to do. I didn't tell it if I'm going for, with friends, for an adventure, for hiking, or for like a honeymoon. It's just going all over the place, but it's giving amazing, amazing, amazing ideas. It's also giving me please do's and please don'ts, and it's being an advisor, it's being a planner, it's being a researcher, right? Transportation and all of these incredible things that it's doing for us. And it's so 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 powerful, right? We didn't have to do any of this. But and great, I will get to this. I'm definitely going to get to this, but let me talk about this. And I'm so glad you brought it up. So the question is, if Claude is doing it, why do I need to really create multiple agents and sub agents, right? Now, this takes me back to my initial explanation, and I alluded to this earlier. There are some agents that we build, and then there are some agents that we use. Now, Claude, or so I'm guessing. So when you say Claude, right, there are two things. One is Claude. So Anthropic has made Claude, which is like the Claude Sonnet or your Claude Opus, which are your LLMs. Those are your large language models, the models themselves that understand language and do next word prediction. The problem with, if you mean your LLMs, the problem with using those LLMs directly is the fact that they would hallucinate, and they don't have enough controls in place to give you the right answer, to give you the most relevant answer. And they're frankly not good enough by themselves. So they need to be given to an agent. They need to be put inside a harness and then made into an agent. And what we're talking about, strands, like what I'm talking about right now, the agent, the open source harness agentic framework, actually uses Claude Opus under the hood. That is the LLM that I'm currently using under the hood. I didn't show it because it was in default, but you can actually say model equals whichever, and you can choose whichever model you want, and you would just add it here. For me, my default model is Claude Opus. So yes, Claude is doing it, But Claude cannot give you the right answer to your question. It's just going to hallucinate. So we need agents that understand what the real world information, relevant information is, and that also have a very specific task and goal to solve. So that's for Claude if you mean the LLM. But if you mean Claude code, right? And I'm guessing you probably mean Claude code. The difference is Claude code is it's a product, it's a developer productivity tool that helps you build what you want to build. This actually is customer facing. So think about this as okay, so let's say this is in production. Let's say today you are okay, here's an amazing idea for how this is different from Cloud Code, right? Let's say I'm on my airline booking website and I am building this website that can book airline tickets domestically within the United States, right? So if I wanted to book tickets from New York to Hawaii, sure, it would find the best flights for me and do it for me. So let's say as the customer, I am walking up to this website and I'm opening this website. I'm chatting with this agent, Claude Code, or sorry, it's not Claude Code, but it cannot be Claude Code. But let's say I'm building this agent and I'm saying, hey, book me a flight ticket from NYC to Hawaii. Cool. Let me do it for you. Let me find out all these things for you. And you're building that agent, right? It knows how to do these things because it's already got these inbuilt agents and tools and it's got access to these things. So it's able to get the job done for you. And so you're like, yeah, okay, this is working great. Good. But in production, the agents, one of the reasons why agents fail is because they can only do the tasks that they have been pre-programmed to do. They cannot think outside. If you ask them to do anything outside of that, they are going to fail. They are going to break. So tomorrow, I'm originally from India, right? So let's say I asked it a question and I say I'm from a place called Bangalore. So let's say I asked it to book me a ticket and I said, hey, book me a flight ticket from Bangalore to San Francisco. This agent, this website that I'm chatting with, the agent, the AI that I'm chatting with on the website is going to fail because it's going to say, I don't know what you're talking about, right? And so what would you do? What would you have to do today? You would have to have customer support on call. You would have to have someone who's handling this call. And I'd be like, I tried chatting with your website. It's not able to book me like a ticket from Bangalore to San Francisco. Would you be able to help me out? That person's going to get on call with me and they'll say, sure, sure, sure. Let me do it for you. And they will manually fix it for me and try to get me to book it if possible. And then they would, raise a ticket back to the back end and say, new request. A lot of our customers seem to want international tickets. Domestic tickets aren't enough. We need to be able to expand this use case to booking international tickets as well, right? And then your developer team would then go in the back end and they'd work on it for 2-3 weeks. And those people, all of your developers who are building this back end and front end and expanding the use case, they can use Claude Code. They can use Claude Code to help them get there. But it's to help them get there. And then a week later, 2 weeks later, after all the PR and after everything, then there would be a new feature that is updated onto the website. And going forward, if then anyone asks and says, okay, book me a ticket from Hong Kong to, I don't know, to like Germany somewhere, right? And these are two different countries. Then it'll be like, sure, I know what I'm doing. Let me do this, right? That is the roadblock with a developer productivity tool, which is meant for your developers to use and then build out features. In this case, it's super different because now this is at runtime, right? Assume that this agent is in production, it's in runtime, it's chatting with the customer, and I'm saying, hey, give me itinerary suggestions for Hawaii, and it's doing all of this stuff, right? And it's saying you have an incredible trip. This isn't enough. This is all that it knows how to do. But now I'm going to say, okay, cool. Um, but also help me book flights from San Francisco, or let's stick to our story from NYC. Okay, so now I'm chatting with this agent and it has no idea how to do it, right? But it's actually going to make up its own agent. So it's saying, I let me add a flight search sub agent to the existing system, and it's doing it in real time. There we go. So now it's got a whole new capability that it's built out on the fly because it's something that the user asked for in runtime. So, assuming that this is what you're using in production, tomorrow, if your use case, if someone comes and adds a new feature and they say, I want you to do this for me, what, instead of the customer representative manually fixing and solving this problem, and or saying, oh, we can't solve it, or it'll take us 2 weeks to solve it, what they can do is, what instead can happen is, this agent would then write this new flight advisor, right, where it says, this is what you do: pricing strategies, booking recommendations, you are a flight expert, blah blah blah, look for all of these things. So it's written up its own tool that does flight advice. And all this person has to do, right, instead of customer support, the roles are changing. The person that you would need is someone who can read this, understand this new code that this agent has written, and approve. They would have to say, okay, this goes, let's push it, it a prod right away. Or they would say, yeah, nah, we're not doing this, decline. Or say, do it, but make some changes to it. This isn't good enough. I want you to make some changes to it. And so the user will wait maybe an extra 2-3 minutes for their answer, but they are going to get an answer. As opposed, and you have a whole new feature that's been made for you on the fly, as opposed to someone manually doing it, raising a ticket, going back, and, like, you spend 2 weeks solving this in the back end with your cloud code, blah blah blah, and your PRs. You would want to fast track your PR over here. You would definitely want to do the PR, definitely not saying no to that, but you would want to do that in the 2-3 minutes. You make the customer wait at real, like, at runtime, in real time, right? That is why dynamic reloading of these tools is super super powerful. So now it's saying, okay, here is your strategy. So there we go. It's actually saying, right, do all of this and set these alerts, and it's telling us what to do. It's even giving me links to where to go search, and none of this has been taught to the agent, right? It's able to write its own system prompt and saying what it wants to do. Did that answer your question? I hope this answered your question. If I did give it access to direct search as one of the tools, not over here, right? If I gave it access to search, it would directly be able to pull up links and do real-time search. I just wanted to keep it simple, so I did not give it access to search. If you give it access search, it's gonna actually, like, probably look this up and pretty much book the ticket for you. I hope that answered your question for that. Okay. Oh, more questions. I have 4 minutes. Okay, I'm gonna rush. When creating a main agent, what are some stick tools? Yes, I'm gonna get, this is the next thing I'm gonna get to. Can large language models act as self-improving agents without retraining? Slight change of slight reconstruction of your question. Large language models by themselves cannot, because LLM is just something that understands English, but your agents can. Your agent is what has access to tools. It needs access to a tool that can dynamically reload. It needs access to a tool that can access the shell, and it needs to be able to edit files in the shell. So you use an agent harness that will help you spin up all of these additional bits, and then your agent can be self-improving, and that can be done without retraining. But no, your large language models essentially are just there to understand language. They just understand English and Japan and all Japanese and all of these languages really well. If I started telling it, talk to me in Chinese, it's going to start doing it ASAP, because the LLM under the hood is I don't understand Mandarin. So excuse me, but I'm hoping that what it's saying is right? So that's the cool thing. Now, I didn't even teach it how to do it. It's just doing it. Now, this is the LLM that's doing it. It didn't have to create a tool for this because it's the LLM. But if we want it to actually do a task, then we want to use the power of the agent, right? So that's the question for that. So strict tools, great question. This is the most important part that I'm getting to. Evals. this is the most important slide. Four different types of evals. The first one is at a session level. I'm going to quickly go over, do this. Do we have a hard stop in 2 minutes, or what do you think?
We don't have a hard stop. You can continue.
Okay, just maybe 5-10 minutes then, if that's okay. I got too excited by all the questions. So first part is session level, right? If I tell it, hey, did you book my flight? We actually want to evaluate whether or not it booked the flight. So it measures the end-to-end goal. That's one type of built-in eval. The second type of built-in eval is hang on, is at the trace level. So when I say something like check my balance and it starts predicting which your balance is so and so, is that the type of answer that you expect, or are you expecting a different type of answer, right? Is this even the type of answer? Is it helpful, this type of answer? The second thing is, did it hallucinate? Did it make up the answer, or is this actually the answer? Do you actually have $500, right? Faithfulness evaluator. This is at the trace level. Then you want to do it at a tool level. You want to say, if it gives you the answer, did it use the right tool here? Is this the right tool that should have called? Should it have called get account, or should it have called something else? Then is it using the right parameters within the tool? Is it actually for account ID 123, or is it something else, right? We need to understand it at a tool level. And finally, we need to understand it at an output level. We need to figure out if the final answer is the right way. Did it respond in the right tone, the right way you wanted it to do it? Did it call the tools in the right sequence of orders, or did it mess it up with all of your swarms and workflows and everything? Did it do it the right way? And then how is that inter-agent coordination? What does that look like, right? Is it sending the right messages from one to the other? What is the quality? How does that look? And all of this together is our full end-to-end agent conversation. We need to have evals to figure out how well this is doing. And with great power comes great responsibility. So thank you for asking the question on strict rules, because yes, 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 yes. Because this is so powerful, we need to have really solid guardrails in place. We need to constrain the environment. We need to make sure it's sandbox. And another cool thing that Strands has right now is something called micro VMs, your micro virtual machines, where the execution environment is sandboxed. And this is different from your regular sandboxed, where this code is sandboxed. What that means is you're protecting the code from the rest of the world, right? But that is one type of sandbox. The type of sandbox that we need is where it's being executed. So this code, if this gets executed in this environment, the environment needs to be sandboxed. And so micro VMs is something that Strands has. And so you can ensure that it's not just going and deleting random files or creating like 10,000 random tools and 10,000 random files without your permission, right? And yes, the read only by default, write only requires intent. We need to constrain the tools. We need to have allow lists. We need to have retries, rate limits. We need to have isolation. We need to constrain permissions. Who's got access to it? Which users are allowed to talk to it? Maybe only a pilot team needs to talk to this. Maybe not even your users, right? What authorizations do you have? And we need to make sure we have human approval for high impact actions. I will not let this agent anywhere close to answering legal questions, finance questions, or self-analyzing questions on like, tell me what your architecture looks like, right? None of that proprietary information, no cybersec related information should be given access to, right? And we need to make it observable, which is with evals, which is with your OTAL and telemetry. We need to have all of that to make this safe, because it is super, super powerful, but it's also important as developers to make it as useful and helpful and as reliable as possible while being responsible. And that is my big spiel. Before I finally end this cool idea of where we started, of self-evolving agents, I want to talk about where we started and where we're getting to. The first thing that we saw today is agents that build their own tools. The next thing we looked into are agents that can create their own agents dynamically. And the third thing, which we couldn't do today, but in the future, maybe I can talk about it, is agents that can actually update their own source code. And fun fact, Strands agents is able to do that. You know why? Because initially, when we wrote Strands agents, when we wrote down this entire library, we wrote it in Python. So we built the Python SDK version of it. And the fun fact is that the Python version of Strands wrote the TypeScript version of Strands by itself. So yes, it is able to update its own source code because it wrote the TypeScript version of itself, the TypeScript SDK of itself by itself. And so yes, they can update their own source code, and this is so amazing. Resources for you to look into. And I'm happy to share the slide deck to the team and to everyone watching this online. But if you want to take quick screenshots, feel free to do that over here. These are your resources. And if I may move to the next slide, what other questions do I have? Oh, yeah, thank you. Thank you for having me. Finally, where is my slide? This is me. Thank you so much for having me. It was an absolute pleasure, and I love the questions. I love everything. Feel free to connect with me on LinkedIn if you want the code. I'm happy to share it with you. Anything at all, I'm more than happy to share it with you. I'm gonna stop sharing my screen now, and I can take any more questions that we have.
Thank you, Sandhya, for the amazing session. It was very, very knowledgeable, and we learned a lot of great comments for you in the chat. Everybody are just mesmerizing the topic. Is there any questions in the chat more? Do you have any questions for her? Please connect with her on social media. Yes, huge applause from everyone to you.
Thank you. Thank you so much for listening. Um, I would be the happiest if we all, um, you know, take in the whole all of the changes that are happening in the AI world, and we're able to work with each other, learn from each other, share, and just grow as a community. And we are, and I think I am sitting on the shoulders of giants. The reason that I've come so far is because of everything that everyone in my life has done for me. My mother is a single parent, and I watched her struggle, and she instilled so much. She worked so hard to get me to where I am, and I am so grateful and indebted to her and to all of the women in my life. And if I can pay that forward, if I can help the next generation of students, of people who've taken a break because of whatever reason, if they're coming from, if they've recently gotten married or going through divorce, or like having kids, and for whatever reason, if people have taken a break, or if they just started, right? If they're just like, I want to get started, I want to know what this is about. And whoever wants to get started, whoever wants to learn, I want to learn with you. I want to get on call with you, and let's figure this out together. Thank you for having me, and I'm so excited. Any takeaways would be helpful for me.
Thank you so much. We are honored to have you today with us. It was a pleasure to have you. And we're looking forward actually to have you soon again, whenever you want to join and having a time. Thank you for
Yeah,
everyone being part of the event today, having the amazing questions. And I don't see more questions for you today. And we're going to close the session. We have been honored to have you today. Thank you so much.
thank you, Maria. Thank you, Violina. Thank you, everyone.